Hi everyone. By continuing the previous video, now we are going to discuss about the ripple voltage. Please refer below description for the previous video. The ripple voltage is nothing but the variation in the capacitor voltage due to the charging and discharging of the capacitor. As we know, capacitor will charging up to the peak value and it will discharging up to input voltage exceed the capacitor voltage. Smaller the ripple voltage will provide best filtering output. Then we can call it as VR. If we consider this as a capacitor output, this is the peak value and this is the minimum value. And the difference between the peak value and the minimum value will be the ripple voltage. And we can express the ripple voltage as VR is equal to Vp minus Vd on divided by F into RL into C. Here Vp is the peak input voltage and Vd is on is the voltage drop across the diode, F is the frequency and C is the capacitor value and RL is the load resistance. So we can decrease the ripple voltage by increasing the frequency and the load resistance or the capacitor value. For example, if you use the large capacitor value, the ripple voltage will get reduced. And if you want the more accurate value, then we can use this formula, that is equal to Vp minus Vd on raised to 1 minus e raised to minus 1 divided by F into RL into C. But we can get the approximate value of the ripple voltage by using this formula. Let us consider an example. Here we are considering V in is equal to plus or minus 4 volt. And forward voltage of the diode Vd on is equal to 0.7 volt and load resistance RL will be 1 kilo ohm and capacitor C1 will be 100 microfarad. Now we will calculate the approximate value, which is equal to VR is equal to Vp minus Vd on divided by F into RL into C, which is equal to 4 minus 0.7 divided by frequency 50 Hz into load resistance 1 kilo ohm into 100 microfarad. Which we simplify this, we will get 660 millivolt. For accurate value, we are going to use this formula. VR is equal to Vp minus Vd on raised to 1 minus e raised to minus 1 divided by F into RL into C, and which is equal to 4 minus 0.7 volt raised to 1 minus e raised to minus 1 divided by 50 Hz into 1 kilo ohm into 100 microfarad. If we simplify this, we will get approximate value of 598 millivolt. Let us verify this in simulation. This is the input voltage we are going to apply at the source. This is equal to plus or minus 4 volt and this is the output voltage we are getting across the capacitor. If I zoom in here, we are getting maximum voltage of 3.29 volt and similarly we are getting minimum voltage of 2.75 volt. As we know, ripple voltage VR is equal to peak voltage Vp minus minimum voltage of the capacitor discharge, which is equal to 3.29 minus 2.75 voltage, which is approximately equal to 0.54 voltage. Approximation calculation and the practical calculation and the accurate calculation is nearby. Hope we have understand how to calculate the ripple voltage in the half wave rectifier circuit and what happens if we increase the capacitor value and resistor value and the frequency. Thank you for the watching.